In algebra, we need to be able to translate between words and math. So we need to make meaning of math or use math to model real-world situations. We have to be able to pick out keywords. Here we have a phrase, 5 less than a number. Now, a number is usually not going to be in the real world, that phrase. It could be a number of chairs or some amount of people. So our job is to choose a variable to represent this phrase. Now, normally when we're given a real world situation like chairs or people, we would pick C for chairs or P for people. Here we don't have any context, so we could pick any number we want except for E and I. E and I are those two numbers or two letters that are kind of reserved for numbers. There's some other ones, but those are the two main ones we want to stay away from. Less than and more than are tricky. When we see less than and more than, we're actually reversing the order. So 5 less than a number means we're starting out with some number and we're subtracting 5 from it. Remember, we can use any letter except for E or I to represent the phrase a number. If we have the product of a number and 7, the product means times. A number, we can use any letter, so let's say G. So G and 7. I can't write it this way. When we're writing products between variables and numbers, we need to write it as 7G. Here's a two-step, the quotient of a number squared and 3. So quotient means divide. A number squared, I'll say y squared and 3. So I'm going to take y squared and divide it by 3. I could also write it as y squared over 3 because that means divide as well. If we start with the algebra and translate to words, I can say the product of 5 and a number, and I'll use the phrase decreased by 3 because then I don't have to change the order. Another example, 4 plus y. So I can say a number more than 4. Because more than tells us I have to reverse the order.